Welcome to the video presentation for our paper, Diffusion for Out-of-Distribution Detection on Road Scenes and Beyond. In this work, we present a new benchmark and a new model for out-of-distribution detection on general natural images. This work is on out-of-distribution detection, or short OOD detection, for semantic segmentation. In this task, a semantic segmentation training dataset is given. It consists of images and dense segmentation masks labeled based on a predefined set of semantic classes. Everything that belongs to this set of predefined semantic classes is defined as in distribution. At inference time, the task then is to detect all out-of-distribution entities, or in other words, to segment all pixels that do not belong to the in-distribution categories. In previous years, research on OOD detection has mainly focused on road scenes. This typically involves a rather low scene complexity and diversity of OOD objects. Further, all common benchmarks define a rather small inlier distribution consisting of the 19 semantic classes from cityscapes. As we believe that a more general setting is also relevant, this work aims to extend the task to general natural images, which induces a higher complexity and semantic diversity. To this end, we introduce the so-called ADE-OOD benchmark, a benchmark for OOD detection on general natural images, and a method called DUDE, which models the inlier distribution with a diffusion model and copes well with the increased semantic diversity. The proposed ADE-OOD benchmark contains 111 samples. As shown below, each sample consists of an image and a corresponding segmentation mask of the OOD entities. The benchmark defines the 150 semantic categories from ADE 20K as in distribution, which comprises many commonplace categories, for example, computer, streetlight, or river. The images were selected from ADE 20K and open images to contain a variety of OOD entities. The ground truth OOD segmentation masks were created semi-manually using SAM. A key characteristic of the ADE-OOD benchmark is its high diversity. It defines a large in-distribution ontology consisting of 150 categories. This poses a challenge for OOD detection methods, which need to model a more diverse in-distribution semantic landscape to successfully recognize the outliers. The test images feature diverse indoor and outdoor scenes, including a high variety of OOD objects, for example, kites, pizza cutters, or disc golf baskets. Further, the benchmark features high-quality annotations and is compatible with the commonly used ADE 20K dataset and models trained on it. In addition to the benchmark, we present a novel approach called DUDE, which stands for Diffusion Score Matching for OOD Detection. As shown by the blue block in the figure, DUDE operates on features of a segmentation model, which is a transformer that was trained for semantic segmentation on the in-distribution data. As shown in the green block, DUDE trains a diffusion model on features extracted from the in-distribution dataset. For the diffusion model, DUDE uses an MLP architecture instead of the commonly used UNet architecture. This prevents reconstructing OD features through extrapolation and leads to better qualitative and quantitative results. For further details, please see the analysis in our paper. DUDE builds on the connection between diffusion models and score matching to compute OOD scores at inference time. For this, as shown in the figure at the transition from the green to the yellow block, it first perturbs the input x0 with noise epsilon to obtain xt. It then estimates the score s theta, the gradient of the inlier log density, with the diffusion model. Finally, it computes OOD scores as the directional error, or in other words, the cosine dissimilarity between the perturbation epsilon and the estimated score s theta. We compare DUDE to the state-of-the-art in OOD detection for semantic segmentation on the established road scene benchmarks Road Anomaly, Fishyscapes, and Segment Me if you can. We use the AP and FPR metrics. In the table, we color methods according to their ranking. For completeness, our evaluation includes approaches that use outlier exposure or are designed specifically for driving scenarios. However, we do not include those methods in the ranking as they build on additional data or assumptions, which make them less general. The evaluations show that no approach performs consistently well on all considered benchmarks. The proposed method DUDE is more consistent and achieves the best average performance across the benchmarks. In some cases, Dude is on par with methods that use outlier exposure or are driving specific. Further, we provide quantitative and qualitative results of state-of-the-art methods and Dude on the proposed ADE-OOD benchmark. We observe that all evaluated methods achieve their worst quantitative results on the ADE-OOD benchmark as compared to the road scene benchmarks. From this, we conclude that the proposed benchmark is challenging for all approaches. Dude copes well with the increased semantic diversity and performs second best in terms of AP and best in terms of FPR. However, overall, there is much room for future improvements. To summarize, we extend the task of OOD detection for semantic segmentation to general natural images. For this, we introduce the ADE-OOD benchmark, which stands out by high diversity. Further, we introduce the method Dude, which uses diffusion score matching for OOD detection and copes well with the increased semantic diversity. In our paper, we provide extended analyses on the design choices and contributions of Dude. Thanks for watching!